We live in the Milky Way, a galaxy of hundreds of billions of stars. And like everything in the universe, our galaxy is moving. It's not drifting aimlessly, it's being pulled. Every second, the Milky Way and its neighboring galaxies are racing toward a mysterious point in the sky, hidden behind our own galactic plane. This point is called the Great Attractor. And for decades, astronomers have struggled to understand what it is. The Great Attractor is not a single object, but a gravitational anomaly, a concentration of mass so powerful that it influences the motion of galaxies across hundreds of millions of light years. Yet, we cannot see it directly. It lies in the zone of avoidance, a region of the sky obscured by the dust and stars of the Milky Way. Today, we're going to explore this cosmic mystery, what we know about the Great Attractor, how we discovered it, and what it tells us about the large-scale structure of the universe. A peculiar motion. In the 1970s and 1980s, astronomers began mapping the motions of galaxies in our local neighborhood. They expected to see a smooth expansion, the remnants of the Big Bang. Instead, they found something odd. Galaxies, including our own, were not moving away from each other in a simple straight line. They were being deflected, as if something massive was pulling them. A team led by Alan Dressler and Sandra Faber measured the velocities of hundreds of galaxies. They found that our entire local group, the Milky Way, Andromeda, and dozens of smaller galaxies, was moving at about 600 kilometers per second toward a region of the sky in the constellation Centaurus. That's over 2 million kilometers per hour. But what was the source? The direction pointed toward a spot that was largely hidden from view. The Great Attractor had been discovered, but it could not be seen. The zone of avoidance. The problem with observing the Great Attractor is its location. The Milky Way is a flat disk, and its plane is filled with dust, gas, and billions of stars. This region, known as the zone of avoidance, blocks visible light from beyond. It's like trying to see a streetlight through a thick fog. For decades, astronomers simply could not see what was behind the galactic plane, but there are ways to peer through the dust. Radio waves and X-rays can penetrate the obscuring material. Infrared light can also pass through, though with some absorption. In the 1990s, astronomers used radio telescopes to map the velocities of galaxies in the zone of avoidance, revealing the presence of massive structures hidden behind the Milky Way. What they found was surprising. The Great Attractor was not a single object, but a complex region containing several enormous galaxy clusters. The Norma Cluster. One of the most significant structures behind the zone of avoidance is the Norma Cluster, a massive cluster of galaxies about 220 million light-years away. The Norma Cluster contains thousands of galaxies, each with billions of stars. Its total mass is enormous, perhaps 10 to 100 times the mass of our local group. But even the Norma Cluster is not massive enough to account for all of the gravitational pull. Later observations revealed that the Norma Cluster is part of a larger structure. The Great Attractor is actually a supercluster of galaxies, sometimes called the Great Attractor Supercluster or the Laniakea Supercluster's core. It includes the Norma Cluster, the Hydra Centaurus Supercluster, and several other concentrations. Together, they create a gravitational well that explains the motion of our local group. But the story doesn't end there. The Shapley Supercluster. In the 2000s, astronomers realized that the Great Attractor itself might be part of something even larger. The Shapley Supercluster, a massive concentration of galaxies about 650 million light-years away, is one of the most massive structures in the nearby universe. It contains thousands of galaxies, and has a total mass millions of times that of the Milky Way. The gravitational pull of the Shapley supercluster is so strong that it influences the motion of the Great Attractor region itself. In other words, the Great Attractor is not the ultimate source. It's an intermediate attractor. Our local group is being pulled toward the Great Attractor, and the Great Attractor is being pulled toward the Shapley supercluster. The universe is a hierarchy of motions, with larger and larger structures exerting their influence. Our home supercluster. In 2014, a team of astronomers led by Brent Tully proposed a new way of mapping the universe. They defined the Laniakea supercluster, a vast region of space containing about 100,000 galaxies, including the Milky Way. The name Laniakea means immeasurable heaven in Hawaiian. Within Laniakea, all galaxies flow toward a central region known as the Great Attractor. Laniakea is enormous, about 520 million light-years across. Its shape is complex, with filaments and sheets of galaxies converging on the Great Attractor. This new understanding showed that the Great Attractor is not an anomaly. It's the gravitational center of our local supercluster. But even Laniakea is just one of many superclusters. The universe is made of these vast basins of attraction, separated by cosmic voids. Dark matter and the missing mass. When astronomers calculate the mass needed to explain the Great Attractor's gravitational pull, they run into a problem. The visible galaxies and gas in the region account for only a fraction of the required mass. The rest must be dark matter, the invisible substance that makes up about 85% of the universe's matter. The Great Attractor is a region where dark matter is concentrated, pulling on ordinary matter. This is consistent with our understanding of cosmology. Dark matter is distributed in filaments and halos, and the densest regions become the gravitational centers of superclusters. The Great Attractor is essentially a peak in the dark matter distribution. We cannot see it, but we can feel its gravity. It's a reminder that most of the universe is hidden from our eyes, detectable only through its effects. Is the Great Attractor a threat? Could the Great Attractor pull our galaxy into a collision? The short answer is no. The motion toward the Great Attractor is not a fall, it's a slow drift. The Milky Way is not going to crash into the Norma cluster anytime soon. In fact, the expansion of the universe is pushing galaxies apart faster than the Great Attractor can pull them together. The gravitational influence is significant, but it's not strong enough to overcome the overall expansion. Moreover, the Great Attractor is about 200 million light-years away. At our current speed of 600 kilometers per second, it would take billions of years to get there. By that time, the universe will have expanded so much that the journey may never be completed. So, the Great Attractor is not a cosmic danger. It's a feature of the landscape, not a trap. A mystery partially solved. The Great Attractor was once a profound mystery. Astronomers could see its effects, but not its cause. Today, we have a much clearer picture. The Great Attractor is not a single monster object, but a region of space where multiple superclusters converge, filled with dark matter and thousands of galaxies. It's the gravitational center of the Laniakea supercluster, our home in the cosmos. But mysteries remain. We still don't have a complete map of the Great Attractor region. The zone of avoidance still hides many structures, and we are still refining our measurements of the Shapley supercluster's influence. The Great Attractor is a reminder that the universe is dynamic, that galaxies are not fixed in place, and that there is always more to discover. What do you think? Does the idea of being pulled toward an invisible mass excite you or unsettle you? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious and I'll see you tomorrow.